Hi, my name is Rob Martinson, CTO at nLIGHT. On behalf of our global engineering team, it is with great pleasure that I introduce a remarkable breakthrough in laser technology. We call it Corona. Corona lifts one of the most fundamental limitations associated with lasers since their inception over 50 years ago: the ability to control a laser's brilliance with simplicity and speed from an all-fiber architecture. Let me explain the significance of this. Choosing a laser for a particular application, whether it's for cutting, welding, or anything else, depends strongly on the beam characteristics. The size and shape of the spot, its rate of divergence, and its distribution of intensity are all very important. Changing the beam quality to address different applications required the purchase of multiple lasers or implementing very expensive accessories. These legacy approaches to variable beam quality introduce significant complexity and cost. In fact, we can identify numerous other issues responsible for limiting the acceptance of these legacy approaches to the industrial market. nLIGHT's new generation of industrial fiber lasers highlight the simplicity of Corona. Programmable brilliance from a single, small format fiber laser, enabling great versatility for machine tools and numerous degrees of freedom to dial in process recipes. Our customers are no longer limited to just a stationary beam profile. They can now switch between a broad palette of beam profiles and do it fast, meaning on the fly and in real time. And of course, implemented with elegant simplicity so it's easy to use and it's highly repeatable. Our customers can now be equipped with a powerful toolbox of spatially controlled brilliance that adapts to the specific operation they're performing and the particular type and thickness of metal they're working with. This idea of using software to make photons programmable is truly revolutionary. Let me illustrate 3 examples of how this is benefiting our customers. For machine shops that cut metal, users have been forced to choose between buying a laser optimized for thin or thick metal. So what do? They have no choice but to buy multiple tools. Now, with the programmability of nLIGHT's Corona fiber laser, machine tool OEMs in essence have multiple lasers in one, enabling a single cutting tool to process thin to thick metal with the quality and productivity of several optimized laser tools. We expect this to save our customers and end users tens of thousands, if not hundreds of thousands of dollars. The second example is for additive manufacturing. Here, the programmability is leveraged to deliver the optimal brilliance for printing fine scale, intermediate, and coarse features. Configuring the laser like this in real time and on the fly can save up to an order of magnitude in cycle time, dramatically reducing the cost of 3D printed parts. Laser welding is a third example. The brilliance versatility of Corona can be applied to high-speed switching between shallow conduction welds and deep penetration keyhole welds from a single laser without an expensive beam switch. Spatter from the weld pool can be reduced, and the width of weld beads can vary on the fly to execute near-perfect joints, despite imperfections in fixturing, edge quality, and part-to-part tolerances. We've engineered Corona to be powerful, reliable, and easy to use. Our engineers think it's cool technology. Our customers agree. I'd like to now hand off to Brian Victor, nLIGHT's Global Manager for Laser Applications. He'll speak to some of the finer points of how Corona is bringing distinct advantages to our customers doing laser cutting.
Typically, fabricators use multiple laser cutting tools to optimize performance for different metal thicknesses. A small fiber for cutting thin sheet, a larger fiber for cutting thick plate, or you can change out a focus lens and sacrifice productivity. Corona offers this same flexibility by changing the beam characteristics inside of the laser. With the same laser, we enable high-speed cutting on thin sheet and excellent edge quality on thick plate, like this 25mm mild steel. With the largest Corona beam diameters, cutting performance on thick mild steel is exceptional. With an optimized kerf and perpendicular edges, thick parts drop freely from the skeleton, making part removal easy. In fact, for oxygen cutting of thick mild steel, the edge quality with Corona is similar to CO2 laser results. On medium thicknesses, Corona offers small spot sizes for maximum speed, or intermediate spot sizes to produce wider kerfs. The wider kerf optimizes gas flow for improved edge quality and reduced dross. Corona incorporates the same back reflection protection embedded in all nLIGHT's fiber lasers, which is extremely valuable for cutting reflective metals like copper. For thin sheet cutting, the smallest beam size has the highest power density and the fastest nitrogen cutting speeds. Corona is capable of rapidly switching between different beam characteristics at full power to enable fast transitions from piercing to cutting on the fly. While these examples show the performance benefits of Corona for metal cutting, these same features also add powerful capability for welding, additive, and other industrial laser processes.
As you can see from these results, we're onto something that's pretty exciting. Corona, a new type of industrial laser where the brilliance can change on demand to optimize process results. It does this with the inherent reliability of an all-fiber architecture. Beautifully simple, durable, and easy to use. As a laser engineer for most of my adult life, it seems we're entering into a new era of laser design. One where lasers become versatile, multifunctional tools that better meet the needs of the industrial market. Corona, with its programmable brilliance, makes it the laser for the fourth industrial revolution.